An AppSec talk. This is a very much technical talk. Could I get a show of hands for who's looking for AppSec, red teaming, pen tester? Good. Okay, you're in the right place. This is great. All right. A little bit of background. So a lot of my experience was informal. I was a bad teenager. I did a lot of hack learning. So I've been doing this for a long time, and then I was a software engineer for about 10 years and found red teaming very interesting when I realized it was a real career path, and then moved to a technical lead position where I was training pen testers for a little while. And these days, with AI and everything, I'm mostly in the R&D space doing a lot of AI for offensive security and defensive security. So ask me anything. I do a lot of stuff. I've been a bug bounty hunter. A lot of these 0 days are my CVEs or smaller CVEs chained together, which you'll see how that works. So yes, ask me anything. So I'm also known for writing bots. So if you're familiar with the SkyTalks, I did a SkyTalk about some of my bots. They're kind of insane and somewhat unrelated. The underlined one here, though, is all the exploit stuff that we're going to be talking about. But feel free to ask about this sort of stuff as well. Just take a picture of it. I'm going to move on pretty quickly. But we're going to focus on automating exploit chains today, particularly brand new ones, so 0 days. Let's see. Some topics. We're going to do a AWS server compromise. So this is an RCE, remote code execution, via a insecure web application, right? So not AWS's fault, but if you host something bad on AWS, it's hackable. That's where I'm at, right? So command injection is another one. It's going to be a few different pieces that work together to create a really nasty attack. And then some general vulnerabilities and trends that I've been seeing in the industry over the past 5 years, at least. So one thing I wanted to start with is third-party stuff. I've heard a lot of stuff at this conference about third-party vulnerabilities. It's a big deal. So supply chain, make sure your supply chain makes sense. Know where you're getting your software from, who's supporting it, that sort of thing. So if you have something that's not being used anymore, such as an old admin console or debug console of some sort, someone might be using it maliciously, like an attacker, like in this example. So we're going to look at a lot of layers here. And when I say layers, I mean across a company, right? So companies can have many different layers. In this illustration, we've got a software company because we have coding and testing and implementation, but this is kind of a macrocosm of other companies that this could be, right? So almost every role in an organization is involved in the failure or success of an attack. So if you are a defender, this might be of interest to you, that almost everyone has a part to play. This, and in many other attacks that I'm going to show you, and these are real-world attacks, so some of them are redacted, but you're going to recognize some details in them where, you know, in my case, it usually starts with an application exploit, right? And so then it's a little bit of validation bypass, and then we get into like the networking ingress as well, that we're trying to actually pull down malware and install it. And of course, whitelist can't help with that if you're being clever about it. And I'll show you examples as well. So if these things are done right, you stand a better chance of this stuff not happening to you. But there's a way around everything. So I'm kind of speaking at this from a defender viewpoint and an offender viewpoint. So real stories. All right, so throughout this story, think about how new updates and new versions are installed in software that you use, right? So in a new system, you may have old functionality left behind that was used for upgrading, and that's exactly what happened here. So this is the server compromise via that web application issue. And this is the first real example. They're all going to be very redacted, just like this one. And the whole presentation is like this. So anyway, imagine a web application in this example where we've got this admin panel, which, by the way, I was able to access with some privilege escalation because that was an unrelated issue outside the scope. But imagine that any basic user can access this admin panel where clearly you're allowed to upload your own jar file. Jar files are executable Java. We can maybe make our own Java, which would be great as an attacker, and then upload it. So that's what I do. There's an unrelated vulnerability as well. There's cross-site scripting in this site as well. And I just want to point out that typically, the more little exploits you find, the more likely there are to be one terrible exploit. It just seems to be how the odds work out. But just because we're not using it here doesn't mean we won't do something similar in the future using XSS. In any case, when you upload it, the XSS is in this file, this field that describes what the file is. And so now I know I've successfully uploaded this patch, and I'm going to show you what's inside the jar file and what I've actually changed inside it to start doing my red team stuff, right? So, or in the case of bug bounties, your offensive stuff. So in the jar file, it's okay if you can't completely read all of this or if you don't understand code. I'm going to take you through the different examples of what it does. In the very top, I want to know what kind of user or account or role I have right away, because that's going to determine the rest of my chain to figure out, do I need to escalate privileges? Am I going to have to go use Juicy Potato or do something weird on the back end once I get there, or do I already have admin? And so in this case, it actually returned that I had some EC2 users, some sort of like standard AWS account, and it didn't look very high privileged at all. But I'm going to go into why that actually wasn't accurate and what to do about that. So that's the first step, is figuring out who you're running as. The second one there is to try to write files just to see, do I have access to read or write files? I try to write right away because generally if you have write, you also have read. But then there's another one at the bottom that is reading a WinINI file just as an example of, oh, I can read it. And I am looking for a place to look at the output of this jar, because if you think about it, it could be a blind command injection if I didn't have a way to pull it back. In this example, when I upload a jar, you actually see log files that come out as you're uploading it. So I'm actually going to do all of my reconnaissance through the log. All right, so it's just going to display right to the browser once I'm done pushing the jar up. So when I read a file, it's just going to show it to me, which is really nice. That does not happen a lot when you're doing exploits, that you get this nice non-blind way of doing this. So what I said before, thinking that maybe I'm going to be stymied a little bit because I'm running as a low-privileged user, I actually was a very high-privileged user. So what happens is with Java, you have this Java virtual machine, which is a virtualization of whatever environment basically compiled the Java. So you've got these environment variables that when you, oh, I have another screenshot of it here. In the bottom screenshot, you can see system.getProperty in Java. I'm asking for the username, and I'm getting whatever was sort of freeze-framed in when it was compiled at compile time. So it's not a real user. When I go to run CMD, who am I, through Java, like if I spin up a process in Java and I write to the file and say, who am I? I'm actually NT system authority, right? So NT authority system, which is the highest level of privileges you can have on a Windows box, right? So I couldn't believe that, but it was a good lesson. And just a good note to self, if you're a pen tester, please keep that in mind. Sometimes the system lies to you. So when people ask how to remediate this stuff, I mean, I usually start with make sure you're truly a low privileged user, right? Not that it can't be escalated, but it's a general good practice. HMAC, so some kind of thumbprint or something, if you really need to run these commands that actually let you touch code and actually patch code and run executables, definitely make sure it's thumbprinted or whitelisted in a way that you shouldn't be allowed to just do whatever I did, writing files all over the place or what have you. And of course, egress rules, right? So there was a part in there where I was actually downloading my own installs of things. That shouldn't be allowed either. Networking can help you with that. So you can see how all of these things together sort of create this nice effect where it's more secure, not guaranteed, but those are some of the pieces that went together in this situation. So another part of this hot topic of third-party vulnerabilities, let's talk about that. There's also dependency confusion, which is not part of the scope of this talk, but I thought it was important at the time. And so, of course, a famous one was Log4j. These are all third-party libraries that sometimes are dependencies of dependencies of dependencies, so you could really start digging, and then you may end up with a CVE way at the end of the chain where, you know, it's just a dependency of a dependency. But we're going to talk about another RCE that also leads to server compromise here as well. So critical attack chaining, this is command injection via cross-site scripting. So, I could go into detail about what every OWASP category is and sort of do that textbook thing of all these textbook examples, but you find a lot of weird and dangerous things in the real world. So I'm using another real world example. And so I'm hoping you can apply it right away by seeing something real here. And this is one of those things that seems like the truth is stranger than fiction. It's just a bizarre, contrived situation, but it really happened. And again, it's redacted. So we have another web app, and it's a field that is vulnerable to cross-site scripting. It's also vulnerable to other things like CSRF, but we're going to use the cross-site scripting in this example to chain and sort of take control of the remote server. All right, so when we look at, the source code of this page, which is, Fisher-Price, baby hacker's first tool is inspect element, right? So we're going to look right at the inspect element and see what's going on here, what's being sent from that field. And we see there's a string of parameters that are going to come in handy later. So when you do this post request from this field and you hit that button, you're going to have place equals somewhere, fruit equals banana. Obviously, those are made up, but we're going to find them later on. So through other vulnerabilities, we come across the script itself that you can actually download from the page. So this test button here is something you can press and access scripts. And just to shorten the story, this is the script. So it's a .bat script, right? And so we recognize the parameters that we've seen before. What can I do with this? Can I command inject this from that field? Obviously it's a bat script, so it's running on probably a Windows machine, right? I think that's the only place bat does run. And so we've got starting to get our foothold here. We're starting to figure out, what can we do here? So this heavily implies that we can control the HTML parameters that get sent to this file, and that we might be able to do some batch injection. So if we know a little bit of that, or if ChatGPT can go write us some batch or whatever, we can throw it in here. And so that's what I do. I put in the cross-site scripting field all of this other stuff where you can kind of see where I've used this double quote to sort of end the request early and sort of start the batch code. And I think at this point I'm just using WScript. It's a fairly standard shell. And you can definitely Google that, I encourage you. It shows you how to run this CMD calc script. So I'm just going to pop calc here basically and just show that I was able to execute something. And you're on your way, and that's a critical, right? So that was a scary one. And cross-site scripting is nothing to sneeze at. It's just not command injection, right? So I really try to go for that gold of a critical. And on the pen test that I would put out, if I have a 4.3, like something that's kind of weird, like that command injection, that it is a problem, but there's no way to actually get the vector that'll do that, then it's a 4.3, right? So the difference between risk and impact is what's the odds of that actually becoming an issue unless there's another issue to combine with it to actually get that RCE. So this could have been, all right, these are both a medium and a high, but instead I raised them both to high and called it critical because of the situation that it created, which was severe. So there you go, that will elevate. Oh, and this works for bug bounties as well. If you can find a few different things that are smaller that chain together well, you're going to get a bigger payout, right? That critical translates to more money, so if you do bug bounties. And so this is yet another command injection example. I published this as a CVE. This was actually my first CVE ever. And so what this was doing is, this is a reporting library. It's for making reports. It's for, I don't know, budget stuff or what have you, but it's just to make a report look pretty. That's all this code does. And the code itself was actually, in the report, it was actually all XML, and it was hidden in base 64. It had C# in base 64 of all things. And the base 64 C# was stuff like, make the font look like this, make the italic or the size or whatever. And it was all these sort of innocuous C# things that really, frankly, shouldn't have been controlled by the client side, because obviously I'm going to try to change that code. And that's what I did here. So in this screenshot here, you can see that all the white text is what was originally in there. And I really love this at the end. It says, do not modify. I'm going to modify it. That's kind of what I do. So all the red is stuff that I added and it accepted. And I make it sound really easy, but this took me like 43 times. I mean, it wasn't letting me import certain libraries. Like if you look at the top, it's hard to see, but it says using system.diagnostics. System.diagnostics is how I'm running process to actually go pull down my malicious stuff, my shelter, my unicorn payload, whatever it is. All that stuff really relies on me being able to run that process, you know. And I like to take the easy way and try to use a default shell, which this largely is a default C# shell from inside Kali. So it took quite a few times to do that, but it did work. And so I end up with this. I get my Metasploit thing. So once I have this Metasploit shell, obviously it's pretty heavily redacted. I realize that this is also running as NT System Authority, and this is a really good example of why you do manual pen testing too, because it can be really tricky to evaluate this yourself when the app itself wasn't running as root, but the process was, which is really kind of weird to think about, but that was the case here. And I think it's because this was a application using a library that was a separate process. It would spin off processes where for some reason it's compiling this code from the report that gets pushed up, right? So it's kind of unusual to see that, but we love unusual as an attacker. And so this is a lot of time to be in a system, by the way, to go, you know, carefully pull this apart, figure it out. I think it took me like 2 or 3 days. And, you know, this is why we have MDR systems, right, to like sort of monitor this kind of stuff when the attacker's trying 44 times, right? It's pretty loud in the logs. And so what I usually do to try to remediate command injection is to give a really either too broad of advice to help or too detailed to apply to everybody's situation, because it's such a broad attack. And in general, I just say just sort of pay attention to where users are able to control intercepting, deleting, or uploading files. That's usually a really good weak point. Integration points are also good for this. I saw someone talking about GraphQL and SQL injection earlier. So there's a lot of really crazy ways to do command injection. And also think about low-cost open source. Proprietary software does this too. I don't mean to rag on open source, but generally, if there's something that's less supported, it's going to have more holes, right? So some things to consider if you're a defender. Business logic validation bypass. Now, there are human things that humans do that scanners don't figure out very well. I say that with caution because it's 2024 and we've got LLMs that actually are very good with context for figuring out things like this. So these are all things like I've actually done as bug bounty things or whatever, and it's not always clear for a machine to figure out where an IDOR is, right, unless it knows the roles that it's supposed to be able to use to do one thing versus another. You know, moving items in and out of another user's shopping cart, that was insane, and it's kind of weird because you're allowed to move your own items in and out, but not someone else, and a machine would have to understand that, right? So kiosk escapes, some of this is just very relative. These are business logic things where if your site's promising anonymity and you have the logs exposed, maybe that's a huge problem for one client but not for another. So I do a lot of consulting and pen testing as well. And so when I come across this sort of thing, I usually have to go talk to the client and figure out, all right, is this important to you? You know, is this severe? Does it impact something else? And of course, can I chain it to something else that has a very objective problem, like taking over servers, like the last 2 examples I showed you, because almost no one can argue with that sort of thing. So if you're doing bug bounties and you're submitting stuff that could be subjective, They might argue around with you. They might sort of tell you why they're not going to pay you. It becomes a little bit of a negotiation, whereas those more objective things are much sweeter. So let's look at some very clearly severe things, right? And so I just wanted to throw this out because, it's, again, 2024, and LLMs are everywhere. You can do this as a defender. I suppose you could also use it as an offender. You can figure out known limits to help with business logic that would otherwise be subjective, right? So you could say, go look at this manual and tell me what I'm supposed to protect if you're a defender, right? Conversely, what you're not supposed to be able to do. So that's kind of a side note. All right, so we're going to talk about third-party vulnerabilities some more, publicly known versus unknown stuff, and then remediations. So generally speaking, I've sort of hinted at this. I do a lot of AppSec, and it's sort of blind to whether vulnerability is something in-house or third-party. It doesn't really matter where it's coming from, right? If it's something that's an issue, it's an issue. You guys are probably familiar with MITRE.org and, of course, the CVE system. But learning a tech stack is extremely important, as we're going to see in this next example, where the more you know about how it's made, the more you can break it. And I always tell beginning pen testers this: if you learn how to make it, you can learn how to break it. So if you can spend a few years as a sysadmin or a developer, you're going to have a lot easier time breaking into cybersecurity if you understand the systems that you want to beat up a little bit, right? So also, we're going to talk about what happens with software with limited support in this story here. So this is an example from a site that was fairly secure overall, and one of the only serious concerns was this third-party library that really didn't have support. So this was a web page where you could go leave comments on an article, okay? So probably what happened here is the client had a web app that they just sort of glued in this plugin for adding comments to a web page. All right, this is pretty common, and so we're going to do some things, some bad things to it. We're going to spoof a user. We're going to delete someone's comment because we've all thought about it, right? If you've been on the YouTube comment section, you've thought about it. And we're going to watch what happens when this is an unsupported library that we need to report on, like if we're the good guys, right? So we are trying to report the stuff, do good vulnerability disclosure, and figure out what happens with that. And of course, we're going to talk about the value of a trial version when you're doing reverse engineering. So we're going to start to touch on reverse engineering a little bit in here as well. All right, so what happens here? When someone goes to put a comment on this site, it sends a request like this one. And as you can see, post comment, right? This is really great to see this keyword key. This is something that if you're hacking and you see the word key, your imagination goes crazy. You're wondering, is this a database key? Is this an encryption key? And just judging by the way that looks and just based on my experience, it looked encrypted, and I wanted to see what it was. So I also noticed that the user display field was also looking encrypted. And of course, the field above that is just plain text. It's just my comment, yada, yada. And so what I did was I took the encryption key and I put it in the field where the user display is to see if it would decrypt it, just in case it was encrypted. So we're kind of just throwing spaghetti at the wall here and playing, because that's what a lot of hacking is, right? You're just trying stuff. And it actually worked. So I was sort of surprised by that. Like, okay, I've got this random string that now looks like a key. What can I do with this? Like, it's displaying this key in the username. So if you know about encryption algorithms, you usually need a few other pieces. You can't just have just the key. Usually you need like an IV, which is an initialization vector. You need to know what algorithm it is and a few other things. And so I want to be able to be any user, right? Like, I want to be able to like put Tom's name in there instead of Erica and that sort of thing, and prove my point on the pen test report, right? So what I'm going to do is do a little recon, and I guess it wouldn't really be Google anymore. I'd probably, if I'd done this in this year, I'd probably be ChatGPT. But so I Google around to sort of figure out the name of this comment library and try to get a free trial version or, an installer. I want to see what's in this code. Maybe the code can be decompiled and I can see what encryption algorithm they're using and maybe even the key. So that's what I do. And it turns out, yes, you can do that. And it turns out that it's got the key in it, yikes, which unfortunately, since that's an installer for everybody, that means I've got everybody's key. So I put together this tool, and in this screenshot, this is actually not the code from the comment library. This is something that I put together to use the algorithm from that source code. Because when you decompile code, it's kind of a mess, and I just wanted to isolate it into a tool that I could use. So I take the IV and the key and everything else that I found from in there, I put it together in this tool, and I'm ready to see if I can, encrypt the name Tom and be Tom, right? So it works. And the really crazy thing about this attack, and when you think about the architecture of the system, is there's no ID related to this user. They were actually using the username as the ID, so there's really no log trail, right? So if I'm the bad guy, you can't see who's deleting whose stuff and all kinds of shenanigans. So just generally speaking for the defenders in the room, I know we're mostly offenders, so I'm just going to be quick with this one. Using OS level API encryption is really great. Not doing it yourself, not rolling your own. It's really highly recommended. Not hard coding encryption keys in source, especially when it's for everybody and it's so accessible. And of course, don't use unsupported software, because when I reported this, the company didn't exist anymore and no one emailed back. I couldn't find them on LinkedIn. Like, it was a big mess. I couldn't really report it. So unfortunately, this is going to stay redacted, this whole story, because I couldn't do good disclosure with it. So another third-party issue, this is a really simple one. Often you don't have to compromise the server completely to cause a huge amount of damage. This is just interacting with the client side. So from an attacker's perspective, I want to be quieter. I don't want my stuff to end up in the logs. I don't want to get caught. So we're going to just engage with the client side only and see what happens. And the way this works is we're going to change a parameter in a file upload request. So that's what this is. This is a snippet from a file upload request where in this library, as part of this web app, you're allowed to upload files. Like I said, it's a weak point. Weak points like this are everywhere, and it's definitely in this one. So when you look at the actual request for the file upload, I can specify my file to upload. But there's also this is replace, which is interesting to me. What does is replace mean? I don't know. I'm just going to flip it from a 0 to a 1 and see what happens. To chain this attack with something else, I'm going to use a path traversal issue as well. If you look below, there's a lot of slashes. This is a classic path traversal issue where I'm able to sort of navigate to a different location on the web server to upload my file somewhere that's not appropriate, which is going to be the actual site content. So we're going to try to overwrite the site content with this is replace and see if is replace allows me to overwrite, and it does. So you can kind of see how we've got this weird access control where it's controlled by the client, which is not good. It's a really unusual design choice. I believe the developer did fix this. They were very friendly about it. And so that was a big help. And the path traversal, there's a few different things going on there. That may be that the web app doesn't have good file permission control either. Obviously, you shouldn't be allowed to do that. This is a very easy attack. As you can see, it's basically just 2 steps, right? You're just thinking about what that parameter means, and then you're putting the file somewhere else. So now the site is, a bunch of pictures of cats, right? Because you can. No, I'm just kidding. We're the good guys. So more attack chaining. So like I said, the more minor vulnerabilities you have, the more likely they'll be chained into an exploit. We're going to look at SQL injection and some unsalted encryption together. And also, it's actually 3 chained attacks here. We're looking at reused file names. Reused passwords. So what does that actually look like? So oftentimes, if you have unsalted encryption, it can be the same as just not having encryption at all. And I'll show you what I mean. But basically, we're going to be looking at a SQL injection with a low-level basic user, and the passwords that get dumped are not salted. So we're going to see some repeats in there, and we're going to start to see that the passwords have been reused, and that gets a little bit scary. So just some example users that I made up here. So you can see that these are these are unsalted passwords because two different users have the same password, but they have the same pattern. And if this had a salt, like a timestamp or what have you, these should be different values, but they're the same. So knowing this and knowing that I have a very liberal SQL injection, I'm going to try to update the password so that the admin user's password is my password. And I don't need to know the admin's password. I don't need to know anything else. All I need to know is that the password, the encrypted password I dumped for myself, is now going to go into the admin's password. So once that is successfully changed, it works. I'm able to log in as an admin. And that was pretty scary. So moral of the story, make sure that your data is salted. Do not reuse passwords. Obviously, that low privilege SQL injection, there really is no such thing as a low privilege SQL injection. It's almost always bad. So there you go. And you can see how these kind of work together as a chain, right? And I should also add, just as an aside, you can use existing CVEs together to create your own CVE, right? So like you can kind of stand on the shoulders of giants. You can have like all these other researchers work with their printing CVEs and using these things. They chain together nicely. Like you can do CSRFs and things that end up ultimately contributing to another CVE where they all work together. So sometimes you see bundles of CVEs together. Obviously in these cases, this is just my work. This whole deck is just me fooling around, but that's also just something to consider. I just realized I didn't mention a lot of other people's CVEs here, and it's important. So some other attack types, I said I wouldn't go over the OWASP top 10. Sorry, I kind of have to. We've talked about a lot of things. I think the only thing we didn't talk about here was, insecure deserialization. So you can kind of see that you guys are probably familiar with this, but if you're not, please check it out. I'm very familiar with the 2017 OWASP Top 10, and I like it more than the 2021 because it really gets to the core of how these attacks work, whereas I found that the 2021 one was just a little too vague. So when I'm trying to teach, I said I was training pen testers before, I try to use this list. I'm not sure if it's trending towards becoming more broader categories for 2021 or something, but there you have it. I like using these names, so I keep doing that. Okay, so like I said, I try to do responsible disclosure. I can't actually disclose this one yet. It is actually a disputed CVE, so I didn't want to include it, but I wanted to include some weird examples of some XSS that I've done. So you can have XSS in social media advertisements, right? If they're using a third-party library that happens to contain XSS for the formatting, that was a cool one. Also consider things like an SVG upload. So that's one of my favorites. It's a picture, but it's made of XML. So XML is just just a broad category of HTML, right, in a way. So you can actually put XSS in it, and it does function. So that's a good one. And file uploads in general, if you can upload HTML, obviously you can put cross-site scripting in there. I'm trying to think of some other weird ones, but yes. So I apologize that this is still not here. But I like to write a lot of tools that sort of fill in some of the gaps with existing scanners, particularly LLMs. You can get some really good cross-site scripting stuff with LLMs, but that's outside the scope of this talk. So anyway, so a very persistent attacker will try to bypass your WAF, your web application firewall, or your URL filters, or what have you. I'm one of those. So I had to dig through a SQL manual to try to find this, to get it to work, and it ended up working. So another real example here, I was using SQL Map at the time, and it wasn't quite functioning the way I wanted it to. I think at times it was crashing the site, and there are parameters that you can play with SQL Map. You can kind of figure out, am I just crashing because it's too much traffic, or am I crashing because there's truly a problem? That can be hard to figure out if you're new. So in any case, I needed a new technique for actually iterating through these errors that I was seeing. So this was a classic SQL injection error where it's gorgeous if you're a new person because you can really see what's going on. It's not like a blind or second order SQL injection and behind the scenes. No, this was actually just spitting out, you have a syntax error, right? Which is a great sign. And it was actually dumping parts of the database, which is amazing. So the only problem is it wouldn't work for like a select star. Like there were certain things that weren't working right, so they were clearly using some kind of keyword filter, and I needed to get around that. So that's what I did. I started to spend some time with the SQL manual for the SQL type that I was using. It kind of looks like in this case it might have been TSQL, just judging from the syntax here, but lead and lag are pretty weird, and as a developer, I never used those, but it was these keywords that let me iterate through each record one at a time and pull out basically usernames and passwords, or so that they would display in that error message. But again, because it's this year and we're all using LLMs to do our hacking now, this is a really nice example of why you might use an LLM for this stuff. LLMs really rock at syntax, coding, that sort of stuff. And we are effectively coding here, right? We are asking for a really specific example of write me a SQL statement for this SQL language that doesn't use the keyword where. That's kind of all I needed, right? I could use lead and lag. I could use a few other things. It came up with row number and common table expressions and all kinds of things that would have been great. It would have saved me a lot of time, because the more obscure or the more number of ways I have something to do something, and the more obscure those ways are, the more attack vectors I have, especially if they're doing this blacklisting where only certain keywords aren't allowed. So if you use an LLM and you turn up the unpredictable functionality, if you have that as a parameter, sometimes it's called temperature. It gives you more unpredictable results. You're going to get the niche ways of doing things because hacking is just a niche way to do something, right? And so this spit out like 10 different solutions for me in like 20 seconds that I could have used instead of spending those 2 hours with the SQL manual. So anyway, so if you're interested in the remediation part of this, what does this look like? A whitelist is always going to be better than a blacklist, but there's a bigger issue here, right? Not just blacklisting some of these keywords, but not allowing the SQL injection in the first place would be good. So there's that. There's an application layer that needs to be fixed here. And also your Band-Aid, your second layer of defense would be that web application firewall or what have you. Whatever you're using for that filtering, it needs to be present as well. So for many of these attack chains, you also end up having multiple layers where you have to be really careful with your configuration. All right. So for my last example, we've got information disclosure. Just because this is low severity does not mean it's boring, and it doesn't mean that the server didn't get pwned, because it did. So it looks like this. This is another AWS server. So this is easily the most common issue I see in like most pen test reports will have some kind of information disclosure. They'll have HTTP banners that display the server version or maybe the programming language, that server side or what have you. And it's just sort of those like little clues that sort of build up together that give hackers that nice insight of the system so that they can go hack it. And this is an example of that, where it's just providing a little too much information. It's giving me a stack trace. This is like candy for hackers. There's so much information in here. And so a little bit of that's my experience, right? So having been a programmer, I know what that means, and I'm going to break it down a bit. So this was actually known for like 10 years, so I almost felt bad making a CVE for it, because some poor developer on their support forums for this company was saying, doesn't this mean that like anyone can just run code through this field? And he was right, and I wasn't really impressed with the response from the company at the time. And unfortunately, it is that simple. It was just a desktop application that communicates to a web server elsewhere. And there's a field where you start putting gobbledygook into it, right? Because you're a hacker and you're trying a bunch of symbols and you're just trying really crazy things. I thought maybe it would be like template injection almost, so you'll see all kinds of like curly braces and stuff like that. So that's what you get this error from, is from typing junk into this field. So legitimate question, it shouldn't show you a C# message like this. And that's what's going on here, is this is C#. So if you look at the top, it's a .cs, which is a C# file. And you've got, basically, it's describing a function that needs 3 arguments in it. So it needs those 3 pieces of information to continue running the program, first of all. So this is crashing, it's stopping. And we don't want to just crash a program, we want to use it the way we want to use it, right? We want to use it to go do bad stuff. So we need it to continue running, so we need to fix this error, which was my entire life for 8 years, is fixing errors like this. And it's expecting an object as one of those arguments, right? So an object is just a data type, if you're not familiar. How many people code here? Is there a lot of programmers? Cool, okay. So there's something called a data type in programming where it's just in this case, it's called an object. So whatever I write in here is going to have to return an object in order to continue running. And we're going to try to write something malicious that will fit those requirements. And in my case, I know that I have to sort of fit in this field, and I can't use curly braces because it's effectively a type of template injection where the code that I'm adding can't have curly braces as well, because in the code somewhere it's using curly braces. It has to be a one-liner. It can't be like multiple lines. It can't be, I can't have semicolons to do multiple commands at once. And I'm finding this out through trial and error because I'm trying a bunch of different C# things, and nothing's really working. But this ended up working after a long time. I put together this one-liner that it basically just creates a HTTP connection to my attack server where I host my bad stuff, and then pulls it down. So there's some parts missing in here just to save space on the slide, but believe me when I say it writes the file down from the internet. And then, of course, I run this entire thing again in that same field to say, now start the process that I just downloaded, right, in mybad.exe. So, yeah, so that's how that works. And again, these days, things are different, right? GPTs are really powerful. If I were to do this again, I would not spend time doing that too manually. I'd probably ask GPT for suggestions like, write this code. So anyway, I know I mentioned AI a lot, but AI is just another tool here. Hacking will always be a very creative and open-ended thing. This is just another way to be creative. And you can chain existing CVEs, or you can roll your own and then chain those. So if you're interested in more of this, please reach out. I blog about almost all of the ones I mentioned on here. And I'm on Twitter/X or Discord as well. Did anyone have questions or any AppSec people interested in this stuff? Oh, yes, hi.
Hi,
Yeah.
I appreciate your enthusiasm.
Yeah, I love this stuff.
Friday. So I lied when I raised my hand if I write code. I mainly read code. I read a lot of code.
Cool.
And I run the static analysis program where I work.
Nice.
So I'm reading a lot of developer code that is suspected to maybe have vulnerabilities. And one I see a lot that developers can push back on is like a denial of service by loop. Familiar with this?
Denial of service by what?
By loop.
By loop? No.
So you're looping over something.
Oh, sure.
Something crashes, right?
Okay.
I just wondered if you had any experience firsthand of kind of like making that type of discovery and
Oh, yeah.
add some color to that.
Yeah, that's definitely part of I'm trying to break this in a way I want it to break, not in the way that it wants to break, right? Because that did happen a lot. So especially writing a lot of custom exploits like this, you do end up with loops, you do end up with things just, it stopped working and I don't have a log and I don't know what to do. And it's totally valid. I've gotten some really weird things that aren't RCEs that still count as pretty terrible DOSes, right? So to rephrase the question for anyone watching recorded, this is about static code analysis and if loops if I've seen loops that can be used as DOSes. And I've seen one of my favorite DOSes was basically an image DOS. So this banner was on every page of a website. And if you uploaded something that wasn't a valid image, the whole site would not display. Like, it would just give up. So just really poor error catching. So I see those kind of DOSes a lot, where it's very much just, man, somebody pushed to prod on a Friday and they were just rushing. They didn't have an error to like catch it in a graceful way. Yeah. Yeah, no, it's a good question. Oh, hey, over there. Oh gosh. Okay. So, so my old boss is really good, much more successful with bug bounties than me. A lot of it's negotiation. A lot of it is having that back and forth with someone that you've just submitted something. You have to prove your point. They may say something like, yeah, you got in over here, but you didn't see anything. And so what he does, and he does it again, and then he goes and says, hey, here's a screenshot, I saw this thing, and then they go, okay, here's your money, right? So really pushing that point and like really getting to the point where you're persuasive and showing that impact, super important, right? And it varies across the different types of bug bounties. So I've been awarded on Yes We Hack more than Bug Crowd or HackerOne, not to say anything bad about those, but it may differ, if that makes sense. Yeah, no, it's very competitive, especially if you're new. I call it free training, but that's very tongue-in-cheek because it's very competitive. So it can be very disheartening if you're new, if someone's already seen the bug, or like in my case, internal red teams have already found a bug, and they just haven't fixed it yet, that sort of thing. But they can be fun. Yeah.
Just to follow up on that, so like there's a couple of these bug bounty websites now, and it sounded like you said you have more luck getting paid on Yes We Hack, but like how do
Yeah.
you decide which one of these companies to start with? Is one
So sometimes it's personal. Like if I just like their product, like one was an alcohol company. I thought maybe the bounty might be their product, right? It wasn't. It was money, but that's fine. I'm not going to be mad. So yeah, sometimes it's like I want to help this company. I want to I like what they do, especially if it's like, I wish they had more like medical stuff, hospitals, things like that, where you're doing something for a good cause. It's I wish I could do that more, but it really depends, like who's offering, like who's running a program, right? And I've run into things where a product I really liked, I emailed them and they said, hey, this is a private bug bounty now. So it's just one of those things where you kind of take what you can get. You're very much at the mercy of the broker or what have you, the company like HackerOne or what have you. Yeah. Yeah. But also report just out of the goodness of your heart too. I've done that too. If there's an issue and you see something, say something, right? That's a little brave to say because you could get in trouble with that. You have to be very careful. You'd want to be very clear and very professional that, I noticed this. I wasn't deliberately trying to do anything. Yeah, because you don't want to get in trouble. So that's a VDP. If you guys aren't aware, has anyone ever heard of a VDP, Vulnerability Disclosure Program? Okay, so even if a company doesn't offer money or doesn't have a bug bounty program in place, they may have a disclosure program in place where they still want to hear about those vulnerabilities. So they basically have a safe harbor where you're not going to get sued if you approach them with something you've found, which I wish more places had that because it's basically crowdsourcing some security for you. I encourage it. I think it's a good thing. People think it paints a target on you, but the thing is, it's like you're going to have that anyway. Like every company is already a target all the time, so I don't know. That's something else to consider is VDP programs, yeah. Any other questions or comments, feedback? This is one of my favorite talks to give, as you can tell. I like OffSec, so. Oh, sorry, yeah. Oh, yeah, so I did a little bit of redacting in these slides, but You can get one on Azure, which is your private instance, especially if you're doing pen testing and you're worried about some privacy issues and that sort of thing. I also went to an awesome DEFCON workshop, and I wish I could remember his name. But anyway, he had a little local LLM that you could run locally. That's a big trend right now, is little mini LLMs, which, can you call it a large language model if it's a mini LLM? I don't know. But it's basically just a smaller example of of GPT with less information, basically less training data, condensed in some way. And so I'm a big fan of ChatGPT as long as you're conforming to terms of service and making sure that everything you do is legal. Someone mentioned earlier on, I think it was in the other 2 talks ago in this room, that there are filters baked into some of these LLMs. Now, filters are going to filter things like hacker activity, right? If you say, tell me how to hack this site, it's going to say no. So if you write to Microsoft, you can remove those content filters, like you can get that approved, and it'll work for things, violence, things like that. But even with the content filter approved, it still doesn't allow hacking questions. So it truly is baked in. Like, somebody made that comment, it really resonated with me, because we, as a pen testing team, can I use it that way? Is there a reason why it doesn't apply? So there's obviously also like Worm GPT, Fraud GPT, things that are obviously very clearly malicious, right? So they're designed for these things. They're not going to have those filters, for better or for worse. So, but yeah, the tech is just insane, because when you can add context to hacking, you really have the keys to the castle. So yeah, I'm really excited to see how it goes. I have a separate talk called Weaponized AI I do, and it's all about offensive AI, and I sort of rehash some classic red team and bug bounty things that I've done, and I show how the LLM can kind of do it too. And a little bit of that's prompt engineering too, right? So if there's any young people looking to get into IT right now, prompt engineering is huge. You can do things that you'd normally need a cert for. It's just a huge compendium of things that, it's able to sort of synthesize information really well and answer your questions and do a lot for you. So definitely a skill I recommend. Yeah. Hey.
Do you know if it's still true that you can bypass those filters by base 64 encoding your query?
You mean in LLMs? Yeah. So maybe that wouldn't surprise me. I mean, with me personally, if I have an LLM that's not quite working right, what I do, full disclosure, I'm not saying go do this to ChatGPT or anything like that, but if you have an LLM that you're looking at, I'll say, how does this attack work? How would I do it in this situation? And how do I defend against it? And usually that's enough nested logic where it's kind of giving you a lot of educational value. That way it's not just super malicious, I don't know. I don't know how long that'll work now that I've said it on a stage. Yeah. Yeah, exactly. This is for my homework. Yeah. It's kind of fun. And someone mentioned earlier on, I think it was actually the 9 a.m. talk in here about LLMs, where they said role is a big thing, right? Like, so you are a pen tester. Yeah. Now you can go do this. You have permission. And sometimes it works, sometimes it doesn't. And, order really matters. I'm a big fan of this YouTube channel called AI Explained, and I'm just hooked. Like, I watch it whenever they have a new video. And it's not consistent output video. It's not like a clickbait kind of channel. They only put out new stuff when there's new news, and they have really good information about how prompt engineering works, how all of this stuff works. Like, it explains one-shot versus multi-shot, and it's been really cool to be able to keep up with it. So, yeah. Cool. Any other questions? I don't know if I'm the last talk in this room, or are you guys kicking me out? Are we? No, you're good? Okay. Yeah, no, I think the future definitely is going to be all about prompt engineering. And the way I look at it is a lot of hacking is just, like I said, super open-ended, where you've got multiple ways to do so many things. I just think of it as yet another idea box. Like, it's just another source of, like, ideas. I don't think it's at the point where it does everything on its own yet, unless you're pen test GPT, which is really cool. It was really cool to learn that it's been doing well on Hack the Box. But, some of the stuff we talked about in here, I used to say machines will never be able to do this, right? So some of that contextual stuff where I'm like taking like this XSS and I have to figure out that parameters they matched in the script somewhere else, and sort of that logic and those jumps to conclusions. I mean, that's intuition that you build up over time, but you could argue that a huge LLM could replicate parts of intuition by just having all that data, right? A lot of data about bug bounty disclosures and things that I do, where I read a lot of bug bounty disclosures and I look at clever things all day that other people have done to sort of learn about it, right? So I think about it as just another brain to sort of assist. So I hope it continues in a good direction, and it's not Skynet, and we've all heard like the dystopia jokes and everything. So, yeah. Wow. All right, thanks, guys.